Okay, the final circle theorem video that I want to talk about is the alternate segment theorem. It's a wee bit trickier, so listen up if you can. It states the following: the angle between a tangent and a chord equals the angle on the circumference in the exact opposite segment. If you can make any sense out of that, you're doing well. Let's talk about what it actually means. I always think about it as a triangle within the circle. So here's my triangle. On one of the vertices or the corners, there is a tangent, and it tells you that this angle here is always equal to this angle here. That's what the alternate segment theorem says. Let's read it out again. The angle between a tangent and a chord, there's our chord, there's our tangent, equals the angle on the circumference, so that's on the circumference, in the exact opposite segment. And so that's it over there. Okay, incidentally, this angle here, if we wanted to call it y, would be the same then as this one over here. Here's how I work it out, just incidentally, if it helps. Let's draw our triangle, and let's draw the tangent somewhere else, so if we can try and get our head around. So if I put my angle here, and let's pick an actual number for this, let's pretend this is 70 degrees, okay? What we hopefully know is that one of the three angles in this triangle is also 70 degrees. That's what the alternate segment theorem says. The way I remember it is it's not going to be this one, because it's right beside my 70 degrees. It's not this one, because this angle and this angle shares this line, so it's the one that doesn't share one of the sides with, so it must be this one here. That's my best way of trying to explain the way it works. Sort of question you might get would then be the following, where you have to try and find x and y. So let's take a wee look. This is 36, so what other angle then is 36? It's not this one, because that's right beside it. It's not this one, because that shares a line, so x must be 36 degrees. Now, why is y not 36 degrees? Because the y isn't actually on the circumference. If we look back up here, it has to be touching the circumference every single time for this theorem to work. All right, so y wouldn't count. And what about y though? That's one of the first theorems that we did. This is 36, and it goes to the end. They're both coming from the same point. Hopefully you can see coming out there. And this one goes to the center. I should maybe define that as the center. So this angle must be twice this angle here. So y in this case must be 72 degrees.